Good morning, everybody. So I'm in actually Blaine, Minnesota today for my son's hockey game. That's irrelevant, but no Murphy and Ava pictures. So today we are dealing with inverses, and we are going to talk about some general stuff. Then we're going to see how to find the candidate, if that is actually the inverse or not, or the function that you find is actually the inverse or not, and why you flip the x and the y when you go through this process. So first of all, the object that you're looking at, the rule you're looking at, must be a function, and that must pass the vertical line test. So, just a quick way to check it. The function you're looking at needs to be one-to-one. That means it has to pass the horizontal line test. Now, if it doesn't pass the horizontal line test, that doesn't necessarily mean you're done. It does mean, however, that you're going to most likely have to manipulate the domain of the function so that it works. We'll do an example of that in time. So what is an inverse? So an inverse is formally a reflection around a line y equals x. So if the ordered pair is 4, 2, and it's on the function, then the ordered pair 2, 4 is on the inverse. Now that's the notation that we use for inverse. So it has an f of -1, but we don't use that notation until we've verified that the function is actually the inverse. Until then, we use g of x or some other something of x. And again, I should be saying f at x and g at x. Now, my first example is going to be f of x is equal to x plus 2. Well, this notation is clunky and difficult to work with, so we just use y is equal to x plus 2. And in the process of trying to find the candidate, you solve for the other variable, or the x variable. So we would subtract 2 on both sides, and we'd get y minus 2 equals x. Now I'm going to pause here for a moment, and I'm going to say a couple of things. We flip the x and the y in math, in mathematical reasoning and so forth, so that we can graph the two functions together. So we can do some analysis to be able to determine if that is actually the correct function. There are times in real life settings where you don't flip your variables, and it is the inverse function. So let me give an example. So I'm eating a muffin right now. It's a chocolate muffin, and we're going to say that the muffin has 200 calories. So the number of calories that I've eaten is going to be 200 times the number of muffins I've eaten. Okay? Well, I could have 2 muffins or 3 muffins or 4 muffins, and I just multiply that by 200, and that'd tell me my calories. Now, what I'm going to do is just say, all right, well, I'm going to turn this over. So I'm going to divide by 200, and I have the number of calories that I've eaten divided by 200, and that'll tell me my number of muffins. So it's actually it's a reversal process that's important there. And real quickly, I have the line y equals x drawn up here. And just suppose that I have the square root function. Now, the inverse of it is the reflection around it. So this is the square root of x, and that's our f of x. Now, the inverse of it is going to flip around the line y equals x. And it works out that the inverse of this is x squared with a little bit of a tweak. We have to make sure that the x values that we choose are greater than or equal to 0. And we'll deal more with that in a bit.